Okay folks, the next problem I want to look at is problem 2 in your book. You can page through chapter 2 and you'll find this scenario. It says, returning from a hike, while on a camping trip, you see that your tent is on fire. Please God, no. Luckily, you are holding a bucket and you are near the river. At what point along the river should you get the water to minimize the total distance you have to travel to get back to the tent? So that's where you are. Your tent is on fire and you have a bucket. So you need to run to the river, get some water and go back to the tent to put out the fire. Okay, so where should you stop here on the riverbank? We're assuming that the riverbank is relatively straight in this problem. Okay, now let's see how Sketchpad can help us. I'm just going to draw any line segment. Then there is where we are now, or where you are, and that is where your tent will be. Okay, so we're going to tell Sketchpad to please measure this distance for us. Okay, or let's just construct the line segment first. Construct the segment. That is going to be a path we're going to walk. So we make the line thinner to distinguish it as a construction that is not final. Okay, so we now need to tell Sketchpad measure that distance. Okay, we're going to call it AB, but I'm going to call this point A. Just for now, I'm going to call it U, like it is in the diagram. So we change it, we click on it and we change it, and it says U to B. Okay, now we can go and we can change B to river. Double click on that and type in river if you want to. Okay, you don't have to. And this point here and that point there is where we want to measure the distance as well. So this point C is where our tent will be. Okay, so if we now measure the distance from you to the river and the river to the tent, we tell the computer number, calculate that distance for us. Sorry, that's my phone. Calculate the distance that we want, which is the river plus this one over there. And we can see that that distance is given to us as what? 18,40. Okay, so let's see what happens. Now we're going to apply again Driscoll's work, vary something and keep something invariant, and see what happens. You are remaining invariant and your tent is remaining where it is for now. Okay, so let's see what happens to this 18,4. If I move to the right, oopsie, it's already less. Now assume if I'm going to move to the left, it's going to be more, and it's going to continue to get more. Let's just check. Yeah, we're already at 20. It's not turning, it's just growing. So I need to get as close to the U component that I can. So we're on 18.7. Let us make this distance, let's change the properties to hundreds of thousands. So we can see when we do indeed have a minimum. Okay, so if I keep on moving to the left, I can watch that. It's 18.62, 6 ones, 5, 9, 5, 8, 5, 7. It's still shrinking. 4, 9, 4, 6, 4, 3, 4, 2, 4, 1, 3, 8. It's continuing to shrink. It's already on 2, 8, 2, 7. Now look at this. The 2, 7 seems to stay. Now it goes higher. 2, 7, 3, 1, 6, 4, 9, 0, 7, 9, 6, 1. So let's just keep an eye on the last 3 decimals over there. Okay, if I go back, 907, 864, 831, 808, 796, 94. 802, 820, it's growing again. So it seems like that's 94, 96, 94 seems to be the best place for me to land on the river. Okay, now what is going on here mathematically? I don't know where to start looking for answers here. So let me measure and just see how big angles are here. So if I measure that angle, I get an angle of 48.49. If I tell it to measure this angle, I'm thinking of the reflexive property or the reflection property in physics maybe. We measure that angle and they're damn close. They're very close in any case now. Okay, so it seems like there could be some sort of relationship happening there. But now we do not have a compass here. We do not have things, measuring instruments. So we must work on principles and on relationships. Okay, so it seems like a good argument would be the angle at which you approach the river should be the same as the angle at which you leave the river. Now, the moment I'm starting talking about angles, I'm starting thinking about triangles. So maybe if I construct a triangle, let's say we want from there to there, and we construct a segment there, is that going to tell us anything? I don't know if it will. Okay, so let's see what that length is. Let's measure that length. Maybe there's a relationship. I don't know. We're looking for relationships now. So that's that length of the one side. And if I ask it to measure that length, the two lengths are slightly different. Okay. So there's a bit of a problem there. Now, how on earth am I going to find the point on that river? That is the important part of what I need to now put on paper here. Okay, so let's see. I've got that those two lengths are definitely not the same. If I move this point, now remember I must keep my eye on the minimums. Okay, there's 794, 802, 796, 808. So we're already getting bigger. Okay, so if I just move my U a little bit, and let's see what happens to those angles. The angles are not really changing drastically. So are those angles going to be different? If I was further away from the river, okay, I moved myself, now I kept my point on the river the same, and I kept the tent value the same. If I do that, I can get those two sides. What I'm trying to do now is I'm trying to get the sides to be equal so that I can see, is this going to be an isosceles triangle? Now look at that. If it is isosceles, in other words, my distance to my tent is the same as the tent's distance to the river, then this angle no longer is preserved. Those two angles are definitely different. The angle of incidence and that angle over there. I also see that my path to the river is not necessarily a minimum anymore. Let's see if that is the case. Now, if I'm going to move this point here, remember I'm keeping my distance to the river and my tent the same. And this is the point that I want to move. So I think we are convinced that there's nothing to do with an isosceles triangle or those angles. Let's see what happens to this component now as we change our point where we get to the river. 55280, 8011, 77537, 505, 72, 6, 8, 6, 4, 6, 2, 5, 3, 4, 9, 4, 6, 4, 5. I get excited every time the third decimal gets the same. So 3, 4, 5, 6, 3, 5, 5, 5, 6. There we go. Okay, so that will be the shortest distance. I can see that these lengths are nearly the same, but they're not. These are very, very close to each other. So if I look at that component, it seems that there's some argument to be made here. So I'm going to bring myself here to the river there. Now I need to try and find where I moved myself again. So let's go to the river. 8-3, 8-2, 8-1, 8-0, 7-7, 7-6. I'm looking 7-5. My distance between me and the point on the river. So I'm looking at this distance here where those two minimizers. That's what I'm looking at. Okay, so if I go there and I go further, 75837, 75853. So 837 and 831, 836. So there we go. Now we can see these angles are still very close. So there's definitely some relationship happening here. Okay, and then the difference between the sides are they're still different. But that's where the minimum is. So now I've got to look at what's happening here to try and find where on the river I need to hit the river. And folks, yeah, you've got to think about this and play around with this idea and then do a few other constructions and try and see if you can answer that question. That's the end of part 1 of this distance problem.